Happy Monday. Just a quick look ahead to this week. We have this week, today we're going to do 7.5, which will be in your white note packet. So get that out at this point in time so you're ready to go when the video kicks in here. Tomorrow you have pre-ACT and forwarded testing. So that means that you will be at school, but we won't have class. Then on Wednesday, we will be reviewing for Unit 6s and Unit 7 for the test. That will then be on Thursday. If you are going to be gone on Thursday, make sure that you take that test before you leave, because next week then is spring break. So you want to get that done before you take off or to go wherever it is you are going. All right, so let's jump into 7.5 notes, and then at the end, you'll have time to be working on your homeworks and all that fun stuff. All right, so we're on page 15 in our note packet. Okay, this regular octagon can be used as a decorative window in the front of a house. Carpenters framed in an opening for it. How many degrees would they need to rotate it to make the window fit into the opening 8 different ways? Well, it's an octagon. Okay, we said so that it's an octagon. That means it has 8 sides. So 360 degrees divided by 8 is going to be 45 degrees. So if they rotate that octagon 45 degrees, it would fit back in. If they rotated it 90 degrees, it would fit back in. If they rotated 135 degrees, it would fit back in. If they rotated 180 degrees, 225 degrees, 270 degrees, 315 degrees, and 360 degrees. All of those rotations would make that window fit back in. And if you'll notice, there are 1, 2, 3, 4, 5, 6, 7, 8 of them. So there would be 8 different rotations because it is an octagon. Okay. And those are all separated by that 45 degrees. Here in number 2, the quadrilateral below is a rectangle. Okay, so what we know about it is we know that it has 4 right angles, or the 4 angles of the quadrilateral. How many lines of reflection does it have? Well, that was from the other day, from last week actually, we talked about that. So it had a line of reflection through the 2 midpoints. It had a line of reflection just through the 2 midpoints, if I'm not mistaken, for that quadrilateral. But then it also had rotational symmetry. Okay? And so we can rotate this 180 degrees and it would map it back upon itself. I'll do that one in red here. So if I draw out this rectangle, and then with my fancy spinner here, I can spin this around, and it spins around to 180 degrees, and it's back upon itself. And then I could spin it around 360 degrees, and it's back upon itself. So for rotational similarity, it has 180 degree and 360 degree similarity. Everything has 360 degree rotational similarity because you're just spinning it around one time. Definition of a parallelogram is a quadrilateral, 4 sides, with opposite sides that are parallel. Previously, we have studied rotational symmetry in quadrilaterals and proved that a parallelogram has rotational symmetry 180 degrees. We did that earlier. Is knowing that a parallelogram have having rotational symmetry enough to prove that the opposite sides of a parallelogram are congruent? Yes, it is, because here, if I show this, so let me figure out how to do this. So if I go with, we'll go with purple. Oh, come back. Whoa, come back. Sorry about that. So if I go with purple here now, and I take those two, and those are going to be opposite sides, and then I can go with a different color. I'll go with green. Those would be opposite sides. And now I can rotate those around and shabam, we have rotational symmetry. So it shows that then those sides, so the green sides matched up on themselves with 180-degree rotational symmetry, and the purple sides matched up on that. So we can mark them. We'll mark them with green. So green will put 1 slash through, and purple we would put 2 slashes through, because those two then would be congruent. So we could then say that side AD is congruent to side BC, and we can say that side DC is congruent to side AB, and that's all because of rotational symmetry. Question number 3 says, would drawing one of the diagonals of the parallelogram provided in problem number 1 divide the parallelogram into 2 congruent triangles? If so, what triangle congruence criterion did you use to decide that the 2 triangles are congruent? Well, let me put one of the diagonals in there. We'll put it in as red. We'll go A to C. Okay. Now the fact that we know that side AC, by the reflexive property, is congruent to itself, now we've got the 3 sides of triangle ACD and the 3 sides of triangle CAB are congruent. So therefore we can say by side, that triangle ACD is congruent to triangle. So we started in between, so that would be CAB. Because we know that those 2 triangles are congruent, then we know that angle D is congruent to angle B by something that we're going to become very, very familiar with. We call it CPCTC. That stands for congruent parts. Let me extend my page here now. Congruent parts of congruent triangles. Oops, correction, not congruent parts. I'm sorry, I screwed that up. It's corresponding. Corresponding parts of congruent triangles are congruent. Okay. But we shorten that up to CP, CTC. Okay? Now, we chose, back up here, we chose diagonal AC. If we would have done diagonal BD, then that would have also created two triangles that are congruent by side, side, side. So then we could also say here that if we use the other diagonal, we could then say that angle A is congruent to angle C. Just the same way that we said in our triangle that we drew that angle D was congruent to angle B. Okay? What this is saying here on page 16, and I'm going to briefly go through here number 1. Okay? What this is saying is if we reflected point A across line BC, so if I reflect point A, then I'm going to have A prime over here. And then that is going to give me a triangle that looks like this. And really, I can break that triangle up into two separate parts. Okay? And then those two triangles, let's call this point here, we'll call this point D. What this is basically saying is that triangle ABD is congruent to triangle A prime BD. It creates two congruent triangles. Then, using CP-CTC, we can say that this side is congruent to that side. This side is congruent to this side. Angle A prime is congruent to angle A. Angle ABD is congruent to angle A prime BD. And then angle D and the angles down here would also be, they look right, but we don't know if they're right or not, depending upon how the relationship is with the point. So we can't necessarily say that, but we can prove it now because those two angles right here, let me put this angle here and that angle there, because they form a linear pair and they're congruent, now we can say that they are right angles. Okay? We can't just assume that they're right angles. Okay? And then the last thing that we would say with that side BD is congruent to itself. Okay? So, here is a rectangle. Okay? So the very first thing that we're given is that we are given that SGMA is a rectangle. And our reason, our first reason is always given. Okay? We want to prove that side SA, we want to prove that this side here, SA, is congruent to side GM. And we also want to prove that AM is congruent to SG, or MA. Okay. Now, a couple of different ways we could go about doing this. Okay? The first thing that we could say is we could say that, flat out, we could go right to it. We could say that SA is congruent to GM, and SG is congruent to MA. One of the reasons that we could say here is we could say rotational symmetry. We just proved that on the last page, on the page right beforehand, we proved that there was rotational symmetry. I'll go back to it right here in number 2, that this has rotational symmetry of 180 degrees, which puts those opposite sides on top of one another. So we have that as a possible answer. The other possible answer that we could also say here is, or what we just proved in a in a parallelogram, that the opposite sides of a parallelogram are congruent. So you've got options there for what you want to put as your reasoning for that statement. But that is a single step proof that we can be done with just one step. Not every proof is going to be that easy. Okay? Here in number 3 now, it is asking, oops, let me cut the brakes. I thought there might have been one more at the bottom down there, but I was wrong. Here in number 3, what else can we prove about the rectangle? First off, we're given that it is a rectangle. Okay, so we're given right here that it is a rectangle. So that would be statement number 1. SGMA is a rectangle. Given. Okay? We want to prove that GA is congruent to SM. Okay? Well, we know that we have right triangles. Because we have a rectangle, we have 4 right angles, so we need to say that. So we can say here in step number 2, angle G, actually because we drew in bigger ones, let's go with a 3-letter name there. Let's go with angle SGM and angle AMG are right angles, and that would be the definition of a rectangle. Now that we can say that those are right angles, now we can say that triangle SGM and triangle AMG are right triangles. That is the definition of a right triangle. Next, we can say we just proved that the opposite sides of a rectangle are congruent. So we can say that SG is congruent to AM. Sorry, I lost my train of thought there. We can say, and that reasoning is opposite sides of a rectangle are congruent. Then we can say that side GM is congruent to side GM, and that would be bireflexive. Then we can say that triangle SGM is congruent to triangle AMG, and my rationale there would be side, angle, side, which then allows me to say that side GA is congruent to side SM by your new best friend in proofs, CP, CTC. Corresponding parts of congruent triangles are congruent. Remember, in a proof, we have to say it before we can use it. We can't just use something if we haven't said something. Okay? Let's switch now to a rhombus. Okay? A rhombus, remember, is a quadrilateral with 4 equal sides. And what they're asking us to prove is they're asking us to prove if the diagonals are in fact perpendicular. So let's first draw in our diagonals. GA and YT. So YATG is a rhombus that was given to us. Because a rhombus has 4 congruent sides, that means then that side YG is congruent to side GT. That's the definition of a rhombus. So I know that I've got this, and I've got this. Let's call this intersection point right here, let's call that point M. If you're looking on your goldenrod toolkit for 6-7, on the back side, you'll see that flow chart. And in that flow chart, when you go to a rhombus has all of the properties of what's above it on that flow chart, which would be the parallelograms properties. Couldn't think of the word property there for a second. Sorry about that. And one of the properties of a parallelogram is that the diagonals of a parallelogram bisect each other. So that means that YM is congruent to MT, So now we know that this side is congruent to that side. We also know then that side GM is congruent to itself from the reflexive. Oops, I put a 4 up there. Should have been a 3. And now I can say that triangle YMG is congruent to triangle TMG. My reasoning would be side, side, side. Which means then that angle YMG is congruent to angle TMG. This angle here is congruent to that angle there. That's our old friend. Corresponding parts of congruent triangles are congruent. I shouldn't say old friend. Old friend for me, new friend for you. Since those two are equal and congruent, and they make a linear pair, that means then that they are both, oops, put M first, plus I want to put the measure there, then that means that the measure, and the measure, I forgot the measure of angle YMG is equal to the measure of angle TMG, which is equal to 90 degrees. Division, that's division, because you got two of them that are the same. Divide both sides by 2, gets you 90, and therefore YT back up to my proof statement. YT is perpendicular to GA. By the definition of being perpendicular. This video will be posted on Canvas. You have the rest of the time to work on your homework for tonight. If you were confused by anything, you can rewatch the video at your leisure, or you can come into the Resource Center and get your questions answered.